Hello and welcome to another Teacher Tobin tutorial. Today I would like to help math or science teachers who want to dip their toes into programming but don't really know where to start. I'm going to use a game that you may have already played in class called Fizzbuzz. You count sequentially from 1, and anytime you reach a number that can be divisible by 3, you say fizz. Any number that can be divisible by 5, you say buzz, and any number that can be divisible by 3 and 5, you say fizz buzz. So 1, 2, fizz, 4, buzz, fizz, 7, etc. until you get to 15, which is the first number, which is fizz and buzz. So with this game, which you may have already played in class, I want to introduce you to programming. And we're going to have two parts to this video. The first part is dealing with the logic behind it, and applying the logic of the Fizzbuzz game to a flow chart, which is going to be the starting point of our program. And then in the second part of this tutorial, we're going to use Python. And Python is a programming language which is very accessible, great for learning, excellent for teachers and students alike, with a fantastic standard library in it. It does almost everything for you out of the box, so it's a great way to learn. So with no further ado, let's start with an explanation of the logic behind this game and start applying it to a programming paradigm. Let's think logically about how we would tell a computer to count but change certain numbers based on conditions, if they're met or not. So this is where we need to be kind of intuitive and think about maybe some of the skills you already know as math teachers. Well, if you have a division here of 3, then you won't have any remainders. There'll be no remainders. 3 divided by 3 is nice and neat. 4 divided by 3 isn't, but 3 divided by 3 is. 5 divided by 5 also has no remainders. So we can use the modulo to work out remainders. If our remainders is 0, then it can help us satisfy a condition. So in this case, modulo 3 would have no remainders, and here modulo 5 would have no remainders. And then Fizzbuzz, modulo 3 and modulo 5, 2 conditions, should have no remainders. So this is where we can use a bit of logic to create some conditions. Let's write this in the form of a flow chart. So let's go over here and we're going to create a flow chart. And this is going to give you the basics of programming, because we're not writing a program specifically yet or with a programming language. We're going to use some pseudocode, a little bit of English, a little bit of language which would normally might be associated with a program. But this is a good way of dipping your toes into some of the concepts. So in almost plain English, we might be able to say something like this: for number in range of 50, let's just count up to 50 to start with, we want to see if some conditions are going to be met. So these diamonds usually denote some conditions. So we've got 3 different scenarios. So we're going to have all of those, and we're going to see if various conditions are met, then we can have a yes. If that condition is met, then we're going to do something. If it's a no, then we move on to the next condition to see if it's met there, and if it's still not met, then we go back up to the top and try another number. So let's put our conditions in. Let's write if number modulo 3 equals 0 and number modulo 5 equals 0. If that condition is met and it's a yes, we will say Fizzbuzz. If it's not, if both conditions are not met, then we go to the next one underneath. We go to the next condition because it's a no. In which case it's if number modulo 3 equals 0. If that condition is met, we say fizz. Say fizz. And as you can see, if that condition isn't met, then we go down into this one, and we just simply say if number modulo 5 equals 0, then we say buzz. If none of those conditions are met, then we have another no, and then we would say number. Say number. Okay, so what happens now is that we've got all these conditions, and we essentially need to loop back here. So once we've set a number, we just go back and go through all the different numbers up to 50. And with these, the same. If we need to loop back here, we all need to come back here, and that's why we call it a loop, because we've started with for all of the numbers in range of 50, starting with 0, 1, 2, 3, etc. We check these conditions. If they're not met, then we just go back and try the next number. So 1 and 2 would not meet these conditions, so we just go back, and then 3 would go down here. It wouldn't meet this condition because it doesn't meet both of those together. It does meet this one, so we go to fizz, then we just loop back, and number 4 doesn't meet anything. Number 5, we go down here, we're down here. It would meet this condition, so then it would just go up here, and we go to 6, etc. And up to when we reach 15, it would actually go here and stop, because it would be meeting both of those conditions, and then loop around. So that's essentially the basics of the logic and the flow that you want to replicate with your Python code. And we're going to use Python because it's a very straightforward and easy and accessible language to use. It's very powerful, actually, and it's got a great standard library in it, which is why it's so popular. And the concepts you learn doing something like this flowchart are actually extremely similar to the code you'll see later when I open up the coding environment. Okay. Thank you for watching part 1 of this tutorial. I hope that the logic behind this was sound, and you can start to see yourself applying the same kind of logic to different problems that we need to solve. The next step is we're actually going to dip our toes into the actual programming environment, so head over to part 2, and as always, do let me know in the comments if this was useful and helpful, and any suggestions for future content. Thank you very much.